The I can statements for Lesson 3.1 are: I can write fractions as terminating or repeating decimals, and I can compare fractions and decimals. For the vocabulary words in Section 3.1, you have a repeating decimal and terminating decimal. I don't necessarily like the definition of a repeating decimal in the textbook, so I looked it up on my dictionary, and it's a little bit better definition in my opinion. A repeating decimal is a decimal in which a figure or group of figures is repeated indefinitely, such as 0.6 repeating, or as in 1.851851851. You can write down either definition, and for terminating decimal, if the repeating digit is 0, then the decimal is a terminating decimal. So 0.25 is a terminating decimal because it stops at the 5. We could write 0.25 as 0.25000, etc. But if it stops, then we call it terminating. If it repeats one number or any block of numbers, we call it repeating. When changing a fraction to a decimal, you have a couple methods to choose from. Number 1, you can memorize them. Number 2, you can use long division. Number 3, you can use a calculator. For the example 1 got it problems, I'd like for you to try using long division. Remember that when you're setting up a problem like 4/5 and converting it to a decimal using long division, the numerator 4 is the dividend and the denominator 5 is the divisor. Since we cannot take 5 into 4, we add a decimal, move it straight up into our answer, and then add a 0. 5 goes into 40 8 times. So the decimal equivalent for 4/5 is 0.8. For 3/16, again, 3 is the dividend, or you might say it's inside the house, and 16 is the divisor, so outside. Since 16 does not go into 3, we're going to add a decimal, bring it up to our answer, and then add a 0. 16 goes into 30 one time. 1 times 16 is 16. 30 minus 16 is 14. We have to add a 0 and bring that down. 16 goes into 140 8 times. 16 times 8 is 128. 140 minus 28 is 12. Add a 0, bring it down. 16 goes into 120 7 times. 16 times 7 is 112. 120 minus 112 is 0, and if we bring down one last 0, 16 goes into 85 times. And so 3/16 is a terminating decimal because it stops after the 5, and the decimal equivalent for 3/16 is 0.1875. Instead of just writing the answers down on your note sheet, please show the work for your long division so that you know this is a method that you can use. 4/5 and 3/16 are both terminating decimals because they end. Next, we will look at fractions that have repeating digits. 1/6 is an example of one of these. This is one that I hope you eventually memorize. I think it's an easy one to memorize because 1/6 is 0.16 repeating. But again, if you do not have them memorized, you can always use long division or use a calculator. Notice on a calculator that it's going to probably show a 7 at the end, meaning that it's rounding the last digit. For repeating decimals, we are going to use something called bar notation. It's a bar or a line that is placed over the digit or digit that repeats. Notice in the table that 0.1666 repeating is showed in bar notation as 0.16 with the bar above the 6 only. 0.353535 has the bar over the 2 digits, And for 12.68 repeating, the 8 has the bar above it. And for the last example there, the bar is over all of the digits that repeat. In example 2, they are using long division to show each fraction as a decimal. After looking through those examples shown, please try the got it problems by yourself. For 2a, you should have gotten 0.83 repeating with the 3 having the bar notation above it. For 7/9, it's 0.7 repeating. At the bottom of page 95, there are a couple of fraction decimal equivalents that you can look at and try to memorize. We will do more in class together. In example 3, you have a story problem where you need to write a fraction and then convert it to a decimal. In the got it problem, we have a fraction of 45 out of 56. You can use a calculator to find that decimal equivalent and to the nearest hundredth find out what part of the time did his shot land on the fairway. On a calculator, I will take the numerator 45 divided by 56 and I get the decimal shown on the screen. If I'm rounding to the nearest hundredth, I'm going to go 2 places to the 0, look to the right, the 3 is less than 5, so I will write that as 0.80, and we can even go a step further to put 0.80 as a percent. That would be 80% of the time that this player had his shots land on the fairway. When comparing fractions and decimals, it might be easier if they're written in the same format. For example 4, you are comparing fractions and decimals. After looking through the example problems, try the got it problems on the bottom of the page. For 7/8, that is one that I have memorized, so if you have fractions and decimal equivalents memorized, it makes problems like this a little bit quicker. 7/8 is 0.875, and that is just a tad bit greater than 0.87. So for 4a, that should be greater than. And for number 4b, we have 7/15 and 5/12. Those are two that I don't have memorized, and it's really hard to do just mental math on these because 7 out of 15 is about half, and 5 out of 12 is about half. So I'm going to pull up my calculator and find the decimal equivalent for each of these. I have 7/15, which is 0.46 repeating, so 0.46, and I'll use bar notation to show that the 6 is repeating. And this is a negative 0.46 repeating. And then on 5/12, 5 divided by 12 is 0.416 repeating, negative 0.416 repeating. And so since these are negative, you have to think a little bit more critically about that. Normally a student might think, oh, 0.46 is bigger, so this must be greater. But actually on the negative side of things, 0.46 repeating is further to the left of 0.416 repeating. So for 4b, negative 7/15 is less than negative 5/12. On example 5, you're doing some more comparing of fractions. One way to do that is mentally, if you can convert both fractions to a decimal and compare them that way. Or you can use a calculator to find the decimal equivalent. For the got it problem, I changed 16/28 to a decimal and got 0.5714. There were some repeating digits there, but I just stopped it at the nearest 10,000th. And for 19/30, the decimal equivalent is 0.63 repeating. So 0.63 repeating is bigger, 19/30 is larger than 16/28. So the question of did a greater fraction of girls or boys see the movie? The greater fraction is 19/30, so the answer is boys. I hope these notes and the practice problems you do for homework make you feel more secure in your understanding of how to change fractions to decimals. Remember that you can always memorize fraction decimal equivalents, you can use long division, and a calculator is also a valid strategy to use.